proofs. It's kind of hard to teach geometric proofs because it's so many different reasons you can use. So like with algebraic proofs, we're going to do 2-column proofs. They also have flowchart and paragraph proof. It's still the same concept. You still have a statement, and then you have something you have to prove. So the reason it's hard, like I said, is with the reasons for algebraic proofs, they were pretty much the ones we talked about: the addition property, reflexive property, all of that. With geometric proofs, you have those same properties you had with algebraic proofs, plus every definition. So definition of a point, definition of a line, definition of a plane, definition of collinear, definition of non-collinear, segment addition postulate, angle addition postulate, definition of a linear pair, definition of vertical angles, definition of acute angles. So like definition of complementary. Everything that we went over so far can be used in the geometric proofs we'll go over. And later on, when we do some other geometric proofs, everything up to that point can be used. So it's a lot of stuff. But we're going to just do some examples, and you have these sheets there, fill in the blanks, so you'll just be filling in the blanks, alright? Alright, we're going to do an example. Hold on. Okay, we're going to look at this first top part. You're using the letters that's just really matching, so you just plug it in. Notice there's only 3 reasons, so one of them is going to be used twice. So one says, the given is ray HJ is the bisector of angle IHK, and angle 1 is congruent to angle 3. So HJ is, number 1 is H is the bisector of angle IHK, so that is B. It was given to me. Alright, then, so HJ, and anything with geometric proofs, you need to always mark whatever they tell you. So ray HJ is the bisector of angle IHK. So bisector means to cut in half or cut into 2 equal pieces. So this piece is equal to that one. Okay. Alright, and they had already told us that angle 1 and angle 3 were congruent. So I'm going to put a red arc mark and a red arc mark for 1 and 3. Alright, angle 2 is congruent to angle 1. The reason that is true is because angle bisector, because when they told us that ray bisected the angle, then we knew that the 2 angles were congruent. So A. 1 is congruent to 3. That was given to us, so that's B. Angle 2 is congruent to angle 3. So if you look at reason 2 and 3, statement 2 and 3, notice that they both have angle 1 in them. So you cross out angle 1, you have 2 is congruent to 3, which would be the transitive property. Alright, so C. And like I told you before, this is a paragraph proof. And you'll have the statements on one side and the reasons on the other side, just like we did with the algebraic ones. Okay. Alright, now let's look at this one. Alright, again, this is fill in the blank. Alright, I usually say I always thought of what was given to you, so angle 1 and angle 2 are straight angles, and that was given. So the measure of angle 1 equals 180, and the measure of angle 2 equals 180. The reason that they equal 180, and the reason you know they equal 180 is because they told you that they were straight angles. So that's definition of straight angle. The measure of angle 1 equals the measure 2. Since they both equal 180, that means you can substitute it in. So angle 1 equals angle 2, so substitution property of equality. And then I was trying to prove that angle 1 was congruent to angle 2, and that since we knew that the measures were equal, that means we know that the angles are equal. So that's definition of congruent angles. Okay, next example. Angle 1 and angle 2 form a linear pair, and angle 3 and angle 4 form a linear pair. That was given to us. That was right here. So that's given. Angle 1 and angle 2 are supplementary, and angle 3 and angle 4 are supplementary. The reason we know that is because that they are a linear pair. So if the definition linear pair. Alright, then the next reason says definition of supplementary angles. So that means that we know that the measure of angle 1 plus the measure of angle 2 equals 180, because if they're supplementary, they equal 180. The measure of angle 3 plus the measure of angle 4 equals 180. And then the last one says the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 equals 360. So that means all they did was add the two pieces together. So since they added, that means our last reason would be addition property of equality. Now remember, this is a paragraph proof right here that we just did. Now technically the answers were all here because this was a paragraph proof. So this is a 2-column proof. I'm sorry, I said that wrong earlier. This is a 2-column proof. It has 2 columns. And this here is the paragraph proof, okay? So notice it says the same thing, the linear pair theorem, and then angle 1 and angle 2 are supplementary, and angle 4 and angle 3 are supplementary. The definition of supplementary states that measure of angle 1 plus the measure of angle 2 equals 180, and the measure of angle 3 plus the measure of angle 4 equals 180. And then you would use addition property of equality to make the conclusion. I know we're doing a lot of examples, but that's the most important part with geometry proofs, is just getting examples. With proofs, you are really just trying to explain the reason behind everything. Like, with a proof, it's using deductive reasoning, using statements, logic, definitions. Think about it like this. If you were a lawyer, you couldn't just go in the stand in the courtroom and say, hey, he's guilty because I just know he's guilty. You have to prove it. You have to show proof based on law that he's guilty. So it's the same thing with a proof. Alright, so we have given AB is congruent to EF, and on this one they already have it marked. You see the tick marks. And B is the midpoint of AC. So since B is the midpoint of AC, that means you know that this is equal to this. Okay? And E is the midpoint of EF, which means, again, you know this is equal to this. Alright? So B is the midpoint of AC and E is the midpoint of DF. That was given to me. AB is congruent to BC and DE is congruent to EF. That's the definition of midpoint. And I suggest you kind of pause me and try to think of it before I tell you what it is, so you can kind of see. Okay? Alright, so notice the only difference between 2 and 3 is that you have congruent and equal. So the answer to this one is definition of congruent segments. Okay. Then we have AB plus BC equals AC. DE plus EF equals DF. So part plus part equals whole, which is segment addition postulate. Okay. Then it says 2 ABs equals AC. 2 EFs equals DF. So you have to kind of look at what you already have on here. So the thing they took out right here was this BC. But if you look at 3, BC equals AB. So of course they can substitute. That's what they did. Here you have they took out this DE here and they put in another EF because DE equals EF. So they substituted. So you have substitution. Then it says AB equals EF, which was given to us. Then it says 2AB equals 2EF. And even with me, sometimes I have to kind of think about it. I'll be like, what? So notice that from 6 to 7, the only difference is the 2. And they're multiplying AB and they're multiplying EF by the exact same number. So that means this would be multiplication property of equality. Okay. Then we have AC equals DF. So notice this AB, 2AB, 2EF. Now we have AC equals DF. Okay. So that would be substitution. Okay. I'm going to have to bring it up. So I'm going to erase some of this other stuff. So we was here with substitution. And then the last one, the only difference is that it has the equal sign and then the congruent sign. So definition of congruent segments. Okay, try the last one. Try. Give it your best shot, okay? We won't, I'm not going to give you the answers here. I'm going to talk about it in class tomorrow so we can kind of see. So try your best, okay? Give yourself a chance, all right? Sometimes some of them make you think a little longer, okay? You're trying to work on your logic, all right? So work on it.